Hello, this is Pat O'Mara. I'm with a number of our good friends from Provenance and Uphold and DeFi Devs and Accumulate Protocol and Klaus. We're so excited to have you here. And as we think about the life cycle of compute directly connected to a distributed ledger and think smart contracts, the question is, what is the life cycle of that smart contract? How do we need to think about compute being directly connected to distributed ledger as it exists today, where it's going to be tomorrow, and where it'll end up years down the road, right? And so we want to talk a little bit about all these things, and we've got just a really super crew here with us. And so I'm going to start. As you guys know, my name is Pat O'Mara. I'm the Chairman and CEO of Invenium. And I'm with Rick Bunker. Rick, you want to introduce yourself real quick?
Hi, I'm CTO and CPO of Invenium. I've had a long career in capital markets IT.
Fantastic. Rick, it's super to be with you again as we bring so many of our good friends here. I'm going to start with Ira. Ira, give us a little bit about yourself.
Hi, everyone. Ira Miller here. I head up engineering for Provenance. I've been in the space since 2018. We've built the Provenance network inside of a company called Figure and spun it out independent in 2021. My background is in research and development. I come out of an R&D space, distributed systems, and kind of emerging tech. And so long career in sort of dealing with these problems of evolving systems over the years.
Yeah, thank you so much. We're super excited to understand your take on this, and not only your take, but Provenance's particular views. Martin, introduce yourself to us real quick, and it's great to have you.
My name is Martin Hiesbeek. I'm head of retail at Uphold. Uphold is a fast-growing retail and institutional trading platform for all sorts of assets. Our primary focus is on serious crypto for serious people. I have been in the blockchain space for 30 years. I did my first work in decentralized computing in the 1990s when I had the honor of meeting Barbara Lischkov. So I've been in blockchain before most of the people who trade these days were born.
It's
a pleasure to be here.
Yeah, we're super excited to have you and hear your thoughts about this. We've been, I read your research all the time. I love it. I think the first time you and I spent a call agreeing vehemently was talking about proof of work and the role of proof of work, and that's when we realized that we shared a lot of similar worldviews. And next, I'm going to introduce Jay. Jay, do you mind introducing yourself? We are going to quote a little bit from Attack of the 50-Foot Blockchain that I got from Jay. He was quoting it to me, so I had to go grab it and read it. And Jay, give us a little bit about yourself.
So, hi, I'm Jay Smith. I'm with DeFi Devs. We're the creators of the Accumulate blockchain, and I spend most of my time helping organizations figure out how to do blockchain better by having an application layer and a data layer within the blockchain. What a strange computer science concept.
Yeah. Thank you. Klaus, we don't have a picture of you, but boy, it's great to have you on. There you go. From an audio standpoint, Klaus, give us a quick introduction of yourself.
Yeah, thank you for inviting me. I hope, can you hear me? I'm sitting in a taxi in Dubai. We had a meeting that ran over time, but I'm definitely here listening and participating as much as I can. I do have a PhD in computer science from many years ago, and I'm running a company that uses smart contracts quite a lot, but I'm definitely not a technical expert in smart contracts. I never quoted a single line, but of course I have an opinion about it. So I'm CEO of DigiShares. We are a provider of white label technology and infrastructure for tokenization. We started 6 years ago, and we've got close to 200 clients globally using our platform.
Klaus, it's great to have you, and I think that Oh, sorry, you're breaking up a little bit. We're losing you. Klaus, we will wait till you arrive at a stationary location.
Really exciting market to be.
Klaus, we're going to wait for a minute. And Paul, I'm saving you for last. Paul is our chief blockchain scientist at Invenium before he went out to DeFi Devs. Before that, he was with Factum and has been in the space, Martin, like you, for a really long time. Paul, thanks for joining us, brother. Why don't you tell us a little bit about yourself?
I'm Paul Snow. I have a background in development environments and compilers and embedded systems that goes back to the 80s and the digital printing revolution with PostScript and that sort of thing. I've created lots of innovative ways to do computation, particularly with rules engines and eligibility determination. Some of my systems are still running in Texas, Michigan, and New Mexico, processing rules developed by subject matter experts rather than developers. And then when the blockchain showed up, I realized a lot of what I have been doing applies. And my early theories in building blockchain protocols was to use the blockchain to hold the data, allow that data to be updated and create provenance of what is behind the computation, and build systems to actually do the computation off the blockchain, but create complete and reproducible audit trails of what that computation was. That aligns a lot with Vitalik Buterin's current theories for Ethereum to move away from holding the data on the moving away from doing the computation on the blockchain, but holding the data on the blockchain. So that's kind of where I am in this discussion.
Thanks. And well, it's good to have all of you. And right, we're talking about a distributed ledger, and a distributed ledger which has a thing on it which represents some things, some value, some home equity line of credit, some limited partnership interest, some whatever it might be. And when it is a simple thing, right? So like all it is floating point, meaning that where is the decimal, right? And one Bitcoin is one Bitcoin is one Bitcoin, and you know what Bitcoin is, and you can disagree about the value of it or the price, but that thing trading back and forth is simple. But when you start to introduce variables that have computation needed to understand the value of that thing on chain, both pre-trade, post-trade, to service it, to automate functionality around it, suddenly you come into the notion of connecting compute to that instrument. And this is really what Vitalik was thinking about with smart contracts, with EVM. And what I'd like to do is maybe just throw it out there for anybody on what is a smart contract and the origin of smart contracts, so that we can then go into the life cycle of it and how long should they last? Are they fit for purpose? Are there better solutions? How have people picked different things? But let's start with what is a smart contract? And I'd if nobody wants to jump on it, I'll throw it to you, Rick. But anybody interested in jumping on that?
I mean, I can answer. It's a little program or constellation of programs, the code for which is stored on the blockchain and which is executed on the nodes of the blockchain in that blockchain virtual machine, which has access mostly only to information stored on that blockchain. I think that's it. The value is that one can call upon a blockchain to do a piece of work, such as to check to see if Paul Snow has the right to transfer these coins from one wallet to another, and check to see if that wallet to which he is transferring it, which is Martin's wallet, is listed
Thank
as
you.
someone who has passed our know your customer and anti-money laundering checks, and for example, and then only if those conditions are met, execute the function, and have that all be contained within the database, which is the blockchain, and operate on each node.
Paul, did you want to add something to that?
Well, I think it's interesting to also say what a smart contract isn't. It's not actually a contract, but a smart contract.
Nor smart.
It's not smart. It's not a contract, but that's what we
It's
call
not
it.
smart. It's not a contract.
Right.
And it's not a token either, even though people will say when they tokenize something, what they've actually done is deployed 19 smart contracts, and they call that a token. The terminology is very confusing.
Yes. Well, what a smart contract can do is automate terms or automate a small process on the blockchain. And I will contend that smart contracts that do a very small, very easily understandable atomic step are incredibly useful and will always exist on blockchains. But there's a point where it breaks, and that's when the complexity gets too high. And like you were trying to say, you create a constellation of smart contracts to build a abstract entity. You're just asking for trouble. I'm not saying it won't work. I'm just saying that's really, really hard, and there's a point where it begins to break down.
And you know, there's a question on the chat where it says, "What are the limitations of smart contracts?" Right? What should they be used for? What shouldn't they be used for? And I'm going to kind of go through it, and we're going to put a few of these things in. But the way I like to frame this is twofold. One, what is, when we think about logic, right, where we're doing any type of logical argument, in symbolic logic, when we're representing that logic out, you know, and this is going back to my days, right, when we were studying symbolic logic, even in undergrad, literally, you know, there are operations, there are constants, there are relationships and variables. My view is really smart contract should be relationships and variables. If this, then that, right? The simplest function, right? And you can string some of these together. But when you get into complex compute, and you get complex operations or constants, things that need to be referred to, you know, calculations that need to be referred to at scale, those don't belong in a smart contract because it just makes it very complex. And really, what is in a smart contract, what isn't in a smart contract is a question. And last week in our group, our head of AI said half of his day is spent on this shouldn't use AI at all, and the other half is, you know, arguing to somebody that this should be using AI. Do you know what I mean? And Rick Bunker jumped in and said, that's how I spend my day. Half of the day is saying this is appropriate for blockchain and convincing some of that. And the other half of the day is this is not a good idea for blockchain, right? And I think what belongs on chain, what belongs off chain, and that architecture matters a ton. And Ira, you guys in building Provenance, you guys made some unique, I would say, decisions architecturally about where you were going to have that compute live. And I want to talk to us a little bit about that.
Sure. So the decisions that we were making for Provenance really come down to when we looked at what a blockchain does and how it works, combined with the experience of engineers who've built systems over time, and more importantly, had to maintain those systems over time. I think that's the piece that I really want to drive home here, is that when we were building this, we were worried about not making it work, but how are we going to make it work in 3, 4, 5 years? And so from that standpoint, a blockchain is just a state machine. It says, given the current state of the system and what you're telling me to do, is it allowed, and what is the new state going to be? And so when we looked at that, we said, okay, what we want to do here is we want to do as much of the computation in the protocol as we can that we're going to use every day, because as we move forward, if you put something in a smart contract, you can end up in a case where as the chain evolves, as the protocol changes, the smart contract doesn't. And then you've got to deal with updating it. And then you end up with these kind of edge cases as the protocol evolves where things no longer work. And so Provenance has, from the very beginning, said, what are the things that we're focused on? Let's do them in the protocol in a well-integrated way and de-risk that evolution over time.
And Martin, I want to come to you, right? Because you look at a lot of chains. You look at a lot of different, as head of research for Uphold, you're looking at a lot of different crypto and the underlying utility of their chains. And you have some pretty definitive views about smart contracts, right? On where they are. I'd love to hear your thoughts on that.
Yes, I do. I think that we have, for the past 10 years, developed silos of blockchains. Mostly these projects are carried forward on the shoulders of young males who treat crypto like they treat their sports activities. You know, my football club is better than your football club. So there's competition on who is the better Ethereum. So we have silos in blockchain. We have programmers that are only familiar with their own backyard. They have no idea how things work on other blockchains. We have a dominant chain, the oldest one, Ethereum, that dominates the discussion and attracts so much development activity that is considered by some as the only available option. That's just not true. So when we talk about smart contracts, we are, in this context, speaking of Ethereum style small snippets of code on a linear blockchain. That is not the only type of blockchain that exists. We have modular blockchain, we have directed acyclic graphs, we have the ability to put entire software programs in what the ICP, or Internet Computer Protocol, calls containers. So it is, a smart contract is the most simple, the most primitive, so if-then statements form of code that you can put on a linear blockchain that has an extremely limited amount of block space. And they don't work with each other. We have zero interoperability between on the smart contract level between chains. And that is not, that's nice for crypto. That's like children in the sandbox on the playground, right? But it is not suitable for use in a broader economic context where lots of different players and countries and industries are involved. We need interoperability solutions. We need the representation of real world assets and digital assets in a chain agnostic manner, so that a contract or a token or an asset can live on any given chain. There has to be, if you compare this to the internet age, right at the beginning, the first 10 years of the internet, everybody was developing their own solutions. And what it all came to was a huge crash in 2001, and then the dominance of huge behemoths of the internet, the Googles, the Facebooks, which consolidated the efforts of thousands of people who dreamed that the internet would give them all sorts of freedoms. The same is true in blockchain. We have just started. We have spent the last 10 years building siloed systems that don't talk to each other, where interoperability takes the form of, I don't know, wrapped tokens, or the ridiculous concept of bridges, which are never safe. We have completely, in most projects, ignored cybersecurity issues. We have an industry of smart contracts that has no auditing standards, right? We have things like, we have auditing firms like Certic who issue the all clear 46 days before Terra Luna crashed, right? they are more interested in satisfying their customers. And it's a bit like the KPMGs and the Deloittes of this world. They also have an interest not to piss off their customers with a bad report. But we have no industry standards in blockchain. We have no authority that says, yes, this is an approved smart contract. This can be used to transfer government funds, right? We have a complete lack of accountability. And on that premise, we are trying to put all kinds of complicated real world assets and billions and trillions of dollars, thinking that it is a complete set of new technologies. It's not. It's a work in progress. And Solidity smart contracts were just the beginning. They are not the future, in my opinion. And as just been rightfully said by Ira, what we need is the effort of companies to make smart contracts future-proof and bulletproof. There have to be standards that the industry adheres to, so that a smart contract in 10 years is still a workable and upgradable smart contract that actually works and works on more than one chain. So there is an awful lot of work to be done in this aspect, and we are only just beginning. As they say in crypto, we are damn early.
Pat, you're on mute.
Thank you. The thing that I'd like to highlight with what you just shared, Martin, is two things. In some cases, we're not going to do away through the power of good pharmaceuticals, good lawyering, or good computer science, do away with all the world's evils. Do you know what I mean? And the reality is, I recall that SocGen won Risk Manager of the Year for putting in place the most robust risk management solutions in the industry. And they were the cover of Risk Magazine. And 3 months later, Risk Manager Magazine, 3 months later, they had the largest write down in history in Forex, right? Where they hadn't conceived of a situation, right? They hadn't conceived of this unique, ingenious person in Baltimore who was finding a way around the system, right? And so these are ever evolving, right? Everything in all systems is ever evolving. And I want to say, what has been created with the EVM and the Ethereum network and the army of developers that are developing code is in fact something of value, that even though it may not be the end state, it's certainly amazing. And Klaus, I want to hit you on that, right? You have a business that is saying, I'm taking this thing, which is not perfect, it's not in the end state, but it's working, and in its state today, there is a business, there is the ability to trade value on chain, there is the ability to tokenize, there is the ability for people to have ledgers in a networked reality where we're not consolidating power. And I really want to talk about DigiShares, because when you talk about your business where people are white labeling your software, why do they want to white label your software, right? What is the problem that they're attacking as they take copies of your software?
Yeah, can you hear me now?
Yes.
All right, that's good. I'm in a taxi in Dubai, and I'm sorry about the poor quality here. So my name is Klaus. I'm the CEO of DigiShares, and I feel a little bit out of my league here, even though I have a PhD in computer science and run a company based on smart contract technology. I know my knowledge is limited. I've never coded a single line. And I have to say that we are sort of technology agnostic in our company. We provide white label software solutions for RWA organization globally. We have around 150 clients in more than 40 countries, and our clients are not tech experts at all. They are conservative, and they know they have no sort of strong opinion about which technology to choose. They just want it to work, and they want it to be interoperable with everything else, right? So I agree very much with what one of the previous speakers said, that to us, performance and sort of the exact quality and sort of qualities and elements and aspects of the smart contract language is not really so important for us. It's more important that it's interoperable, it's standardized, it works across different platforms in the industry. We can issue tokens and mint tokens, or our clients can mint and issue tokens, offer them for sale and so on, and they can be used, traded in other systems, and used as collateral in other systems as well, right? And that's just not possible today because as an industry we're pushing many different protocols and chains and so on, and that's making it really, really hard for companies like us. We are willing to adopt pretty much any standard that has a chance of getting sort of used across the industry, but that's just not happening yet, I would say. I don't know if that was what you wanted, Pat.
It's great, and I think the point is that there's a hunger for a networked financial system where peers can engage with each other and do away with intermediaries that hold bottlenecks. And if we can allow this networked financial system to store value, trade value, deliver the functional transmitting of whether it's a payment or an investment or whatever it may be on a distributed ledger in a networked reality where code is going to bring about the efficiency just like it did in retail. You know, the internet completely disrupted retail. Blockchain is going to do an even greater disruption of traditional banking, right? And we need to understand that this function is first, that has a long way of a ripple effect of these next steps that Ira and Paul and Martin were talking about. You know, we start with something great, and I always love I have a copy of George Boole, who created Boolean algebra, of his first treatise on symbolic logic. And in that first edition, they wouldn't print it without a disclaimer introduction that was longer than his treatise on how purely symbolic logic is bad for a young person's mind. They need to be able to relate to natural language in between the symbols, right? And purely symbolic logic will be damaging to young people, right? And so that little treatise created everything that opens the door for compute, the NAND gate, the NOR gate, right? Zeros, the binary world that we live in of computer science today and programming and blockchain. And you could say, oh, George Boole, he just started it, but he started it. And I think Vitalik has a similar role of the relation of compute. And Paul, you were there at the very earliest of days, launching Factum. And Jay, I'm going to go to you. You've been with Factum and then Accumulate for a long time, talking to people about what belongs on chain and what doesn't. And what are the functions that these smart contracts should automate? And how should enterprises think about what they should do with this and what they shouldn't do with it?
Well,
I'm sorry, Jay, you take it.
Oh, okay. I wasn't sure if it was coming to me. So we've spent decades learning the lessons of how to build good software that is maintainable, that is not brittle, that has good total cost of ownership, and is reliable. Decades doing that, but every time there's a new technology, we forget every lesson we ever learned. You know, one of the core lessons that we've learned is to build systems in layers. You have an application layer, you have a data layer, and you do that for a reason, because it makes the software more maintainable, it makes the software more extendable. And so what's the first thing we do when we build smart contracts is we create a system where the data and the application are smashed together. I mean, we did this in the 90s with stored procedures with disastrous results, and you don't see stored procedures anymore. We've done it again. And one of the and some of the things that have been talked about, like bridges, which are disastrously unreliable. The fact that when you create a security token, it's very difficult to have a token existing in more than one place at a time, because the data and the application are all wrapped together in one package. And this doesn't work. And so one of the core things we've got to do is stop doing that. Use a blockchain data layer, commercial. I mean, that's what Accumulate and Factum before, that's what they were built to do. But if you think about how you normally build systems, where I've got an application layer, and if I've got a customer entity, I can have many different application pieces using that customer entity down on the data layer, because it's separate and therefore it can exist in lots of different places. You can't do those fundamental things, and this causes you to have bridges, which we eliminate bridges completely. You just don't need them. And so, this is one of my biggest frustrations with the state of smart contracts now.
Hey, thank you. Paul, do you want to add to that, buddy?
Sure. I can say that that if you go back to Turing and you look at the Turing machine, you realize that the tape in this model, and I'm going to keep this really brief because it's maybe too technical, but the tape in the model is the data, and then you have a machine that runs over the data to create execution. The fundamental construct of a smart contract is data. It's the data they're processing, and it can be, and the program itself is data that you are executing. So where you do this processing does not have to be on the blockchain in order to get all of the security and auditing and reproducibility of a smart contract. And so once you've lifted it off the blockchain, that means every participant is bringing their own computation to the party. So there is functionally no limitation of the computation that can be done on a blockchain. If everybody's bringing their own computation to the party, that means the computational capacity of the blockchain grows with every new participant. This is exactly what we saw with the internet. The internet exchanged data between servers. Every time you add a server, the internet is more powerful. It's not less powerful, but until we change the architecture of the blockchain, blockchains with more load are going to be slower. Blockchains with more load are going to be more expensive. So there is a solution, and that is to move to data. Now, the other lesson that we learned with the internet is URLs are the way you find stuff. And so this is kind of what we've built into Accumulate. This is what we learned we needed when we implemented Factum. And there you go. I'm going to leave it at that.
Yeah. Great feedback, and really absolute ignorance gives you great freedom, right? If you have no idea what you're doing, you can accomplish almost anything in 24 hours, right? But the more you've been around these cycles and you've watched once or twice, you have to build something that is going to last underneath loads and of transactions that matter and are significant and worth having. Rick, you wanted to make a comment on this?
So I just want to sort of enthusiastically agree with everything that's been said and do a little and. I think what I would like to see, and what Ira can talk to, because with Provenance, they've done some of this, is what currently exists in the EVM world. There's the data layer of the blockchain, and then there's the smart contract layer of the blockchain. And that smart contract layer needs to be decomposed. And a lot of it needs to move off chain, which is what people have talked about. And that can be done securely with zero knowledge proofs of work that's been done, et cetera, et cetera. But the other side of that, which we haven't addressed, which I think is very important, is part of what's currently being done in smart contracts needs to move down into the blockchain protocols. Because there is a place for universally applied rules and regulations and functionality. And right now we see people creating ERC 3643 tokens or ERC 20 tokens which are supposedly a standard, but each company that does them implements them in their own slightly different, slightly incompatible way. And who knows who's got an error or a vulnerability, and they're very difficult to update. But so there's stuff that should be moved down into the chain protocol. And then there's other stuff that should be moved off. And maybe there is still a place for, again, trivial, universally applicable compute in the smart contracts. But that's what needs to be said. Someone asked about MEV and what MEV was. And I just want to, as a quick aside, say MEV is node operators stealing from the people who submit transactions to them for processing.
It's front running.
It's front running in this age, right?
It's been illegal on the regulated financial markets forever, and it's gross.
It's the same thing as payment for order flow, and it's the same thing as front running, right? And it's regulation takes them to catch up.
Maybe 2 points to this. The European Union is just enacting a law, or is discussing a law to ban MEV, which is the first ever in the entire world. People savvy enough to realize that this is an illicit practice. It does have some functionality because you can use MEV to prevent hacks, but that is a side effect that shouldn't justify the use of MEV. But when MEV arrived, I remember being in the Ethereum developer group. When the first discussions on MEV happened, people were simply shocked, right? Nobody saw it coming. And what MEV did, it changed the discussion in blockchain completely. Before, we were talking about block production, finality, and suddenly we had to talk about the sequence of transactions, about sequencing. It has completely changed the development activity. And it ultimately has an effect on smart contracts too.
And it ultimately has an effect on who is utilizing, who the players at the table are, whether they are altruistic, trying to build the next version of financial markets in a networked effect, or to take as much rents out of the trade as they can in the shortest amount of time and then leave and go to the next. And there are these financial locusts who are not acting as liquidity providers. They're purely locusts, right?
We must always remember that all of this started with David Chaum's thesis in 1982, his dissertation, how to establish and maintain and secure a network of mutually suspicious actors. Somehow along the way, we forgot that we should all be mutually suspicious, especially in blockchain, where half the developers are anonymous and on the other side of the world, right?
I'd like to ask Ira.
I want to go. Yeah, I want to throw it to Ira. Ira,
yes, please.
Take Rick's comments and respond, as well as you wanted to talk about bridges for a minute.
Yeah, I actually have. There's so many great things on here. I wish we had like 4 hours to go through this panel because there's a lot of really interesting content here. I guess I'll quickly throw an aside in about the bridges, and then we can circle back. So the bridging concept, it's, there's definitely some negative pieces to it, but I think that there are ways, and there needs to be ways for the blockchains to talk to each other. They just need to be done in the right way. And I think that the starting concept that I endorse there is something that was based on the IBC protocol, where you're essentially saying a state machine commits a transaction that says, I want this other blockchain to do something. And then a message gets copied to another chain, which independently executes a transaction. There's this coordination layer where messages are passed between, and the blockchains can respond to that and take action as appropriate. Versus, I think, kind of the classic bridging cases, I send a token to this thing and it gets locked up by an account, and then it creates a duplicate in another chain. Why are we making duplicates of something like that, right? Like, you're making a huge mess.
It exists. This technology exists, right?
The coordinator function just becomes the target of attack then.
And I want to just highlight, in Venium, we have a number of patents on this, some of which were written quite a long time ago, some of which were written by Paul Snow, right? On this in 15 and 16, right? On why why we need to have this type of an architecture, right? And it is incredibly important. Paul, do you want to weigh in on that at all or no?
Well, I will argue one thing, and that is a bridge has one aspect that is pleasant when you're talking about interactions between separate blockchains, and that is it serves as a point where you do accounting such that the only people that take risk of the bridge are the people that use it, and neither side of the blockchain is compromised by the bridge. So, for example, if you were to literally, like with the IBC protocol, destroy the token in one blockchain and create the token in another blockchain and then allow it to reverse, then both blockchains have to trust the accounting of that token in those spaces. In other words, the bridge allows you to count how many people went over it and how many tokens came back. So not people, tokens. How many tokens went out, how many tokens came in. You can never then generate tokens over the bridge because the accounting will stop when there's no more tokens in the escrow. Does that make sense? You see what I'm saying?
Atomic bridging, this atomic function within the bridging itself has to be maintained, and not a permanent bridging that the throughput is epic. That there is no accounting and
right.
balancing function, which is where a lot of attacks are coming. But I want to go into the topic of today's podcast, right? Which is the life cycle of smart contracts, not bridging. And I think we can have a whole discussion on bridging, right? And one of the functions that we're hitting on is where do we put the compute function? Is it in the chain itself? Is it in the smart contract? Where does it live? And what is the future state of this? And I want to ask, we only have about 18 minutes, and I want to start pulling people into the cheap and easy stuff, right? Which is prophecies about where we're going to go, right? What is the future state? What's coming next? What's a smart contract going to look like in the next iteration? And Ira, you guys embedded some of that core functionality directly into the Provenance chain, blockchain. What do you see the future looking like as you also begin to interface with many different chains, including arguably, I would imagine, the EVM world?
So I think that this is kind of an interesting discussion because when we started implementing these features, we looked at things like the interface specifications for tokens. I disagree that ERC20 is a token. It's an interface specification for how you will talk to each other, right? It doesn't tell you how it's done. It just says this is how we'll talk to each other. I think that one of the things that we found was that it's better to have that implementation directly in the protocol, because when you release new versions of the protocol, you can actually test the integration between the different components, and you can ensure that when I add a new feature, such as like the new group accounts feature, or Provenance added a capability to lock funds in an account, we call a hold module feature, because those pieces were all in the protocol, when that software release happened, all of those things were deeply tested with simulation tests, with integration, unit tests, etc. All those different pieces were on the same playing field, and it was released as a new version that was guaranteed to be interoperable. That was the next version of the protocol. If we had done it with smart contracts, when the new protocol came out, we would have a bunch of smart contracts on the chain, which are potentially incompatible because they do not upgrade on the same timeline as the protocol. And I think as we look to the future, other protocols are going to realize these same things. There are fundamental ways that blockchains talk to each other. ERC20 is a very simple example. This is how we want to communicate about a token. Those capabilities need to be in that protocol so that when those protocols are released, they can be tested and integrated between them in kind of in a seamless way, in a uniform way across these different blockchains.
Jay, when we think about that, there's a risk and a challenge, right, of the decision making of who gets to decide what the next version is, right? How do all the nodes weigh in, and the consensus mechanism? There's in one case, you got MakerDAO at the end, at one end, which can't, is doing a little bit better, but they can't really decide on anything, right? My favorite thing, Paul Snow goes to this Satoshi Roundtable thing that I go to, and my favorite part of that is watching all of them trying to appear in the screen of the camera for the photo at the end. The consensus mechanism is non-existent. Do you know what I mean? Like everybody's in charge and nobody's listening, and it's a 1 minute thing comes a 30-minute thing, right? And MakerDAO, is so unwieldy of a consensus. The other fear is, one person is deciding everything, right? And how do enterprises make decisions about who to work with? What is the consensus mechanism working for me on how these next states are coming about, right? Because I do think that there's spectrum, and I'm not sure that there's one size that fits all. No offense to Accumulate or Provenance, right? Which yours is clearly the best example of all. But Jay, can I throw that to you, or I'll hit it with anybody else who wants to do that?
So, yeah, but Provenance is a good example of they are building things into the network that solve specific problems within an industry, and there are other blockchains that are doing that. Onyx is doing that, and so your question of when I'm looking at what should I use, well, you should use the thing that does for the particular problem you're facing right now, what solves that problem now. And when we see this with the internet, you use the servers, the service, whatever, that solves the particular problem the best. The thing that we don't have right now is the interconnect between what we really need is an internet of blockchains, where if I'm doing this particular type, yeah, I think you and I think a lot alike, where if I'm doing a particular thing, I go to Provenance because they're really good at that. And I'm going to run I'm going to take advantage of that. But, the data that represents what I'm doing is in a data layer underneath, so that when I'm doing a different function, I may actually move over here to Onyx and use it, or use this blockchain over here. And I no longer have to worry about what block, because there is not going to be one chain that rules them all. And this is something that we're seeing is the banks are trying to build these blockchains. The banks are building these walled garden blockchains, and they have this idea that they're going to build stuff there and force all their customers in there and extract rents. And it's going to be a really interesting battle between the financial institutions and the customers who are wanting to use their funds where they want to use them, and the banks are trying to stop them. We're getting into a really interesting world for the next 2 or 3 years.
I want to say something real quick here. Trump got one thing right here recently when he said Bitcoin was the best defense against CBDCs. I would more generalize that. I would say public blockchains can produce valuable tokens because nobody is in charge. And the problem with CBDCs is putting your faith in the issuer. And that may be a bit controversial, but
I think that's fine. But Martin, go ahead. You're in, brother.
Perfectly true. So there's a huge issue with CBDCs. We don't want programmable government big brother money that doesn't allow you to spend it on this or that, right? I think this whole CBDC discussion will evaporate as they move to stable coins. But I am a firm believer in two things. A multi-chain future where the chain you're on doesn't actually matter. In all of technology, my entire career, I have always learned that the underlying technology doesn't matter. I used to build my own computers and worry whether I use this processor or that processor combined with this RAM and how it would overclock. Nobody, excuse my language upcoming, but nobody gives a fuck about what's in the machine. It has to work. It has to do its job. It has to have a user experience. Apple knows that best. Nobody in the world knows what's in an iPhone, but they work, and they work well, and they're appealing. And the current phase of blockchain development is just like the infancy of the internet, the infancy of computers. We used to care what components were in the computer, but the wider audience, the great masses that use the technology, they don't care. They don't need to understand it. The same has to happen in blockchain. We have to have workable internet of blockchain where the actual underlying architecture is just taken for granted and works. And it doesn't matter if it's a Solana or Cardano or an Algorand or whatever blockchain you can name. And I fully agree with the argument that these should be public blockchains, which, if you remember the House here, the Senate, was a House hearing last week, Congress, the hearing on RWAs, right? Public blockchains are basically being vilified as incubators of crime and nefarious activities when they should be celebrated as the only transparent, accountable option that we have. We don't want to give all the blockchain business to the BlackRocks and the Fidelities of this world. There is a crypto spirit of responsible, decentralized development to be upheld. And we must fight this fight of, we mustn't let the politicians and the regulators insist that decentralized networks need to be regulated by centralized authorities. That's not the idea. The idea of a functioning decentralized network is the very nature of it being decentralized and working and being self-regulating and eliminating those malicious actors, not by some government authority saying you can do this, you can't do that. So we have a change in philosophy that has to happen, a change in the outlook on society, and that's not going to come easy. There are many vested interests.
We have 8 minutes left, and Martin, I want to take it because we're going to do a speed round going around, and Klaus, I want to go with you. You're delivering tokenized options to people who want to create representation of financial instruments and trade them, right? What are the functions that you need? And I'm seeing that spinning circle of death where your face is supposed to be. So I think we're going to move off of Klaus. All right, Ira, talk to us. I'm going to you. The future of smart contracts, where is that going to be? Give me your 2 cents.
So a couple of things. We've hit on it. We've talked around this. Everything is about consensus. It's about a group of people coming together and agreeing on directions for blockchains. I think what we start to see with smart contracts is you see a divergence between the protocol and the community that runs the protocol and an entity that needs something that the protocol doesn't do. And so my view is that smart contracts actually typify a small schism in the consensus of the community that's actually running the blockchain. It's somebody that says, hey, I see how your stuff works, but I want to do it slightly different. And that typifies what's happening with smart contracts all over the place and why it's so hard to carry them forward, because it represents a small amount of dissent in the vision of that protocol. And so what I see in the future is that either that tension is resolved and things collapse into the protocol and everybody comes into agreement and the protocol itself can provide those features, or you still end up with that tension and that friction between all those different slightly opposed viewpoints on something like Ethereum, where somebody wants to do, a mime token, or somebody wants to do a regulated finance, and they don't ever quite agree. And so I think in the future, we'll see this network of blockchains, these interoperable blockchains that all have consolidated and optimized on those visions and do it very, very well, interoperating with each other.
And I would throw out consolidated on a series of visions, and other people will have other visions, and the market will flow back and forth from one to the other for the time being in which that is the right tool. Does that make sense? But that innovation cycle is going to continue. Rick?
If that protocol went in a slightly wrong direction and it was less efficient than another one, naturally that capability of interoperable blockchains will cause one to decrease in prominence while the other rises, because it simply does the job better.
Amen. Rick?
Absolutely. Self-balancing.
I've enjoyed the conversation enormously. I just want to throw out right at the end, before anybody can respond, I love CBDCs. I'd much rather have the currency than units in a fund run by somebody extracting some money to run that fund and accepting counterparty risk with the people who operate that stablecoin, that fund. So there's that. And I love the rule of law. I think having all of these global blockchains figure out a way to self-regulate is lotus eating. And it's true that enormous amounts of money laundering and payment for drugs and terrorism have in fact been processed. That's not made up. And so
I think that's a good commercial. Well, no, that's a good commercial for on behalf of regulators, and we appreciate you shilling for them. And if I can say that,
wise one.
Martin, we're going to give everybody a chance. And I'm sorry that was a low blow, but we heard everything you said. We're glad you said it. Thank you, Martin. Anything else you want to say?
I've said enough.
Good. Paul.
I've said enough.
Paul, final comments.
I'll throw in my heresy. I don't believe in standards. It's almost impossible to build a standard before everybody is doing it. So I believe that standards are a spontaneous development in the use of a technology. So I would prefer the standards come after we've nailed down the use cases rather than trying to build them beforehand. And I would also say that I don't believe in the Minority Report. Regulators are trying to stop crime before it occurs. I believe in enforcement. And anytime you talk to law enforcement in the government today, they'll tell you more use of crypto helps them catch more crooks. And if you talk to regulators, they will say the crooks exist because we don't have the right regulations. And there's a balance there, but I think it needs to go more towards enforcement and less towards regulation, because there's just too much capability in the blockchain at this point in time to know what the right regulations are. The entire blockchain would be all the blockchains would be more interoperable today if we had unfettered innovation.
Yeah,
but right now we're tying the hands of innovators.
Hey Jay, your brother. Last final comments.
So I think the next big challenge is figuring out how we're going to do consensus on. We talked about that smart contracts are really interface specifications, and I think the next big challenge is figuring out how we reach consensus, which is somewhat standards, but it's somewhat more than that. And do it in such a way that I can run my smart contract on any platform and have the data in a data layer, and we no longer care if it's Ethereum, if it's whatever.
Klaus,
I got to jump. Sorry, I have a Twitter space to contact. See you guys.
Klaus, any last comments from you, my friend? You're on mute if you're speaking, my friend. I'm gonna go ahead and give the final word then. I want to say I think that it is important that there is a free market of ideas. That these free market of ideas where the market is flowing back and forth, because these ideas have different times in which they are more apt. And the reality is, the ability to cycle up and innovate in these short sprints using open source code allows for innovation at a pace that is really hectic and chaotic and enormous and wonderful to watch and see. But there's a lot of crash and burns. But what you've built Ira, is really taking some of that innovation and institutionalizing it, right? And what that does is it is a slower level of innovation, but it's a more robust, it's a more permanent one, right? And the cycle time is longer, but that's all right, right? And these are the trade-offs, and we need both in a diversity of opinion and free market of ideas for us to take it. But I think that the creation of smart contracts, that's undeniable that it created and kicked off a boom. But the question is, where is it going to go? The life cycle of how we think about it and implement it is going to move on. And Jay, I think we started with you with the final comment. But I'll actually give you one last shot. Anything else?
No, I think I've said enough.
Good. That's a perfect ending for a podcast. Hey guys, God bless you all. Thank you. And we appreciate you guys being here.
Thanks, Pat.
Thank you, Pat.
Thank you very much.